Hello and welcome. What I want to try to do today here is demonstrate Cisco's Hot Standby Routing Protocol, HSRP. What Hot Standby Routing Protocol does is allows us to do away with a single point of failure, which we typically do. In a network like this machine here would have a single gateway, a default gateway, which would send it to either this router or this router. We could maybe configure it with multiple gateways, but then since only one of these is going to be active at a time, if it got sent to the inactive router, then we would go nowhere. So what we want to do is to do away with our single point of failure, a single gateway, and we've done that here with the two gateway routers. But at the same time, we want an automatic failover. So what this protocol essentially does is creates a virtual router here in the middle with an IP address and a MAC address. And what really happens, and we'll kind of look at it, at least my interpretation of what happens, is that when we go somewhere, we go to each of the routers, the traffic goes to each of the routers which are connected to the virtual router. It then determines the active, make this the active router. So this one would be the standby router over here. So our traffic goes through this one. If it goes down, then we automatically switch to the second router being the active router. Network stays up. So we can do this. Problem with this is one of the routers is just kind of sitting there waiting for a failure to take place, which we may or may not want to happen. With that, let me see if I can get up my packet trace. Okay, so here is the topology that we're going to use for this. So in the first one, we're going to use router 0, the one at the top here, 192.168 1.2 on the 192.168.1 network, and 1.3 on router 1. 1.1 will be the HSRP or the virtual interface IP address. That's the one that we're going to use as the default gateway down here on this workstation. We can look at it, and it should hopefully already be configured. IP config, so it's default gateway 192.168.1.1. It will send its traffic to the IP address of the virtual interface. It will then make the decision as to which is going to be the active device. So with that, let us start with the configurations. I've named this one router 0 so that I don't get so confused. So on router 0, we'll do interface gig 0/0. We'll do an IP address of 192.168.1.2, 255.255.255.0, and then we'll give it the no shut command to bring it up. Since all of the devices, interfaces, routers have to match, have to be the same, let's go ahead and make, even though it would be the same, I believe, we'll do duplex auto, and then we'll do speed auto to be sure that we have these things. We're going to give these, the standby commands are the ones that actually configure HSRP. So standby, STANDBY, and if we do the question mark, it's going to want an IP, a preempt, a priority, or a track. Actually up here it says group number, and that's where it's going to be group number 1, IP 192.168.1.1 when we do these things. We can also give it a priority that you can see there, and we're going to give this one a priority of 120. The default priority is 100. What the priority allows to happen is if this router were to go down, and we need to give it the next command, preempt. If this router were to go down and it would then come back up and we wanted it to remain as the system that would take over, we would then configure it with the priority, with the preempt and the priority. The priority of 120 says it is the one that should, with preempt and the priority, that it will then take over once it comes back online. So let's go to the 0/1 IP address 192.168.1.2.2 and we will do duplex auto speed auto and standby 2, and we will do its IP 192.168.2.1 and standby 2. I couldn't spell standby right, did I? Standby 2 IP 192.168.2.1. Did I get it that one? Standby 2, priority of 120, standby 2, preempt, and then we'll do an O shut. So that you don't have to just sit here and watch me configure these things. I'll pause the video and go configure the IP addresses on the other system, and then we'll look at the, I'll do a show run and we can look at the configuration there. I added a couple of things, so maybe when we look at them, it hopefully makes more sense. I put the IP addresses of the interfaces, went back and checked to be sure that they were all right. And my workstations, the gateways were right, the addresses were wrong. You may have seen that when I showed you the IP config. But the one at the top, the router 0, should be the one with the priority. So what we can do is go to our, and see, I've done this just to be sure. Let's do a trace route to the other side. We go through the 1.2 address, this one here. Well, before we go any farther, I said that I would show the show run when we get down to the interfaces. Gig 00 is 192.168.1.3 on router 1, the 1.3 here. It is, where do we go here, the 1.3, I'll get there, duplex auto, standby 1, IP 192.168.1.1. That we did not give it a priority, so it's going to be a priority of 100. We gave router 1 a priority of 120 with the preempt command, so that if it goes down and then comes back up, it should take over as the primary router to do this thing. And then gig 01 to 2.3 address, duplex auto, speed auto, standby version 2, and then standby 2, it's 192.168.2.1. Standby 1 up here was 192.168.1.1. So we have the configurations, and we can go, let's go from the other direction here, and let's do a trace route to 192.1.168.1.100, right? And it goes through 2.2, goes through the 2.2. So let's go in here, and I haven't changed, I haven't saved the the configurations. So let's copy, can't spell copy, run, start, so that we have this, and then let's just go in here and we'll go into it, into the physical here, and turn it off. So all of our interfaces here are down. If we go to the trace route again here, we're waiting and waiting and waiting. It may take a second because we're doing a sim, just so that you didn't have to wait for it to finally make up its mind. The simulators sometimes take a little bit of time to do that. Goes to the through the 2.3, did it a couple of times here because I always panic. So we go through the 2.3. It has kept the communications path by using the default gateway of 2.1, which was the virtual in the middle here, so that we can in fact do this. So let me pause the video and I'll turn the router 0 back on. And the reason I pause it, so because it takes a few seconds for it to come back up, and we'll see if it in fact takes back the control like it should with the preamp. Let me pause it while it starts up. Okay, we're back. You can see everything's green again. Another reason to pause this is I have not configured the switches with PortFast, so it had to go through the 50 seconds of spanning tree in order to bring each of the interfaces back up. So let's go over here and see where we go if we do a trace route 192.168.1.100. Maximum of 30 hops, and we can wait for it and wait for it and wait for it. There we go. It went through the 2.2, so we haven't, it got there and back. Went through 2.2, which is this one up here, which is the one that's configured with the priority of 120. So when router 0 came back online, it actually did resume its duties as the primary router. So the HSRP, the Hot Standby Routing Protocol, works. It's something that gives us redundancy or resiliency when we configure a gateway, so that if a router goes down, then we still can have a path configured to where we want to go, to our gateway, to our ISP. So HSRP, pretty simple configuration with the standby commands. Yeah, and again, the priorities you can configure. So with that, thank you for watching, and I hope this has been useful. Thank you.